Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at the homework for 3.1.3. I think this is a two-part lesson, and so this is part one of the homework where we do problems 23 through 27 or something like that. Starts off with M&Ms to show you the difference between discrete and continuous graphs. Okay, so remember, graphs can be interpreted, right? You got an x-axis, that's your independent variable, and then you got a y-axis. We're trying to look to see how, in this case, the number of bicycles affects the number of total wheels, okay? And so the reason why this is a discrete graph being the kind that you do not connect the dots, is that connecting the dots, these points in between here and here, don't really apply to this situation because you're talking about a number of bicycles. You can't have 1.7 bicycles, right? That doesn't work. You either have 0, you have 1, you have 2, you have 3, or you have 4. And you wouldn't have a fractional part of a wheel either. You either have 2 wheels or 4 wheels or 6 wheels or 8. So that's where the discrete graph comes into play. Based on what it is that your variables represent, it may not make sense to have any fractional numbers as a part of your data. Whereas with continuous graphs, this means that you could actually measure the height of the tree at any point after it was planted. We are just plotting in the nice whole number of years, 1 year, 2 year, 3 year, but there's nothing that says you can't measure the tree after 1.5 years or 2.1 years. So that's where you would use a continuous graph. Remembering, hopefully this was information that was presented to you in an earlier grade, when you're talking about a line, you're talking about a sequence of points, right? Continuous grouping of an infinite number of points that you're not going to plot each or identify each one of those points, so you just make the line to represent all of the infinitesimal numbers of points that you can get between 0 and 1, and the fact that it goes on to positive infinity, meaning you could technically go on for an infinite number of years, although the tree would die and that would be sad, but whatever, you get the idea. Continuous graphs cover all of the numbers in between the points, and the discrete graph, the points only apply to the numbers only make sense for those given numbers within the points. Okay, so I'm not a big stickler in 8th grade math. I have done it myself where it's supposed to be a discrete graph and you accidentally put the ruler down and you connect the dots. You know, I think your high school teachers might ding you. They might mark you off if it's supposed to be discrete, but you accidentally connect the points. But I'm not going to worry so much about that in 8th grade, but we will discuss it often. All right, so let's find the value of the given variable for each one of these equations. So just using mental math without even using the legal moves. Like here, you would subtract 7 from each side. What do you add to 7 to give you 2 for an answer? Since 2 is less than 7, that must be you're adding a negative number. So 7 minus a number gives you 2. That number has to be negative 5. Here you multiply 1/2 times something to give you negative 5. So what do you take half of? It must be a negative number because you're taking half of it and your answer is negative, so it's going to be negative 10. This one, what do you multiply times 3 to give you negative 45? Well, that must be negative 15, since negative 45 divided by 3 gives you negative 15. And here, this is one where oftentimes when you've solved an equation, I see people writing this as their answer, but we don't want to know what the opposite of x is equal. We want to know what x is equal. So if the opposite of x is 2, then x must have been negative 2, since the opposite of negative 2 is positive 2. So that's how you get this answer here. To show your work, you could actually just divide each side by negative 1, since a negative divided by negative gives you a positive, and anything divided by 1 stays the same. So that would technically be the legal move that you would show if you had to record your work. Divide each side by negative 1. Here, half of something is equal to -5, this is the exact same problem as this one. No difference at all between those two. In this case, if you had multiplied 1/2 times x, it would be, oops, what did I do? It would have been 1/2 times x over 1, so you'd get x over 2, and that's what you see right there. And then this one actually has two numbers that work. A number squared equals 9. Well, 3 times 3 is 9, but also -3 times -3 is 9. So when you're doing algebra and you solve this problem, we often will show it like this. So x will be equal to the positive and negative square roots of 9. So you want to take both of your square roots, not just the positive square root. That's when we're doing algebra. In situations where, like when we get to Pythagorean theorem in chapter 9, we will only take the positive square roots. We would only take that one. And I'll explain why later. All right. For the following equations, draw a picture of the tiles on an equation map and then solve. So 3 C's, those are our variables. I mean, I don't know, C, they kind of look like X's, right? They're rectangles that are shaded in that have an undetermined length, even though we know the width is 1. Okay. So 3 C's minus 1, 2, 3, 4, 5, 6, 7. On this side is, oh, what happened? Oh, there it is. Negative C plus a 1. So if we were to, what would we have to do? We would have to add a C to each side and then add 7 to get everything on the other side. So you end up with your 4 C's is equal to 8. And that's how you know that C is equal to 2, since 4 times 2 is 8. And on this side, there's no way to ever make those two equal to each other, because by the time you go through the legal moves, you realize 3x plus a -2 can't be equal to 3x plus 6, right? Because then you end up with, like when you cancel out the variables, you get a statement that's not a true statement. So this is an example of a no solution type of a situation. On your paper, write this equation, okay, and then solve for x. So you got x plus 1 plus a -2 minus a negative x minus 3. So my first inclination would be to do KFC and move all these guys across the street. So we can call that plus a positive x and plus a -3, like we have here. And then you can add your x's together to get 2 x's. And you can take your 1 and your -2 and your -3. -2 and -3 make -5, and then you got a 1 to cancel out a 0 pair to make it -4. And on the right side, these guys cancel each other out. They make a 0 pair, just leaving you with the 6. So 2x plus a -4 equals 6. Now let's go ahead and add 4 to each side to 0 this guy out, and that leaves you with 2x is equal to 10. Therefore, x has to be equal to 5. Once again, I'm going fast. You pause and you make corrections if you need to. All right, a little 5D problem. West High School's population is 250 students fewer than twice the population of East High School. All right, so let's make East High School our x. So 250 fewer means you're subtracting 250 from twice the population. So we're going to double this population, then take away 250. So you could do a guess and check if you wanted to, but just so much easier, if the two schools combined have a total population of 2858 or 2,858, then this plus that, right? This plus that must equal 2,858. So let's combine like terms. Let's add 250 to each side, and then at the end, divide by 3, and you get 1,036. So that tells us the population of East High. So now, when you double that number and then take away 250, no, that's not it. Stop it. Then you would get this number right there. Go ahead and double check that with your calculator and guarantee you that's going to work. And then the last problem, number 27, using the order of operations. We have to start by solving inside the parentheses. So if I take A, that's going to be -4 times -2 minus 6 times -3, then we'll do multiplication. -4 times -2 is +8. And 6 times negative 3 ends up being negative 18. Now at the end, you're taking 8 minus a negative 18. So we're going to do KFC there and change this. Keep the 8, flip that to a plus sign, change that to its opposite. So 8 minus a negative 18 is the same as 8 plus a positive 18, and that's how you get 26. Okay? I'm not going to go through the rest of them. If you want an explanation on how to get these answers, please send me an email or let me know during our Google Meet or during class time if you're in class with me, and I will go over any of those problems. Okay? All right. Take care.